Alright, what's up everybody? Today we're going to talk about the difference between position time data and velocity time data. Right, so these data tables look the same numbers and everything, but you notice that this one here is talking about position, this one here is talking about velocity. So this is telling you where something is at a given time, so where it is at 0 seconds, 1 second, 2 seconds. Right, and this one is telling you how fast something is going. It's going 20 meters per second, 15, 10, 5, so on. All right, so let's look at these one at a time, all right, and I'll show you how they're different. All right, so if you have the time and position, we can find what the velocity is, right? So you would, velocity is the change in position divided by the change in time, right? But this time changes by 1 here, so this is going to make it easy for us, right? We just have to see how much it changes from 1 second to another, all right, and that would be minus 5. Right, between 15 and 10 is another minus 5. Between 10 and 5 is also minus 5. And between 5 and 0 is minus 5. Right? So that's how we get the velocity. So you can see that this is a data table for something that is moving at a velocity of minus 5. Right? It's starting off away from wherever 0 is. So let's say you're standing at position 0. Then this is starting away from you and it's moving towards you at 5 meters per second. Okay, now if we want to find the acceleration from this, then the acceleration is how much the velocity changes. So how much does the velocity change from here to here? It doesn't, right? And the same thing from here to here, it doesn't change. From here to here, it doesn't change either. Okay, so the acceleration would be 0. If you were to graph this on a position graph, it would be starting away from you here and moving towards you just like this. Okay, and actually I have the exact graph right here. This is what that would look like, right? So this is an example of something's moving at a constant velocity. So let's go over to the time and velocity data. All right, so again, same numbers, but this time it's talking about velocity. So that is going to completely change what's going on here. So the velocity starts at 20, and then it goes to 15, 10, 5. Does that mean it's moving backwards? Absolutely not, right? It's saying it's moving forwards because it's a positive 20, so it's moving forwards at 20 meters per second. Then it's moving forwards at 15, forwards at 10, 5, and then comes to a stop. So this is going to be moving forward the entire time. It's never going to move back, right? And then what we can find here, we can find the acceleration. Acceleration is how much velocity changes divided by how much the time changes. And so that would be minus 5. That would be minus 5, minus 5. But this is acceleration, not velocity, right? So this means the velocity is changing at a rate of minus 5. This is an example of something that is starting off fast and then getting slower and slower until it comes to a stop. Right? So the position time graph would look something like this. Right? Starting off fast, you have a steep line in the middle, in the beginning. The slope of this line should be 20 in the beginning, and then 15, 10, 5, and 0, which is a flat line as you get to the end. Right? And this is exactly how the position time would look. Now, how would we actually find these numbers for the position time? That is a little more complicated. Right? It's going to take a little more work. We're going to have to make a velocity graph. So this is V over T. This was an X over T, position time graph. And it would have to go, you would have to start up here at 20, okay, 15, 10, 5, and 0. And then as time goes on, I'll just put numbers on the time axis. Right, it's going to go down to 15, 10, 5, 20. You connect that with a straight line. All right, so if you want to find like the position at 1 second, you'd have to find the area of this shape right here, right? And that is a little triangle here and a rectangle here. So you have to add those together. And if you did that, you would get that the area of that was, this rectangle is going to be 15 because 1 times 15. And this little triangle here is going to be, I think, 2.5, because it's base of 1, height of 5, and then 1 times 5 is 5. Half of that is 2.5 because it's a triangle, so we have to take half of it. 17.5, right? So if I continued this, all right, and then at 2 seconds, I'd have to find the area of this triangle and this rectangle here. If I did that, I'd have to do that here, 2 seconds, 3 seconds. I would find that the position, the displacement, would be 17.5 here. At 2 seconds, it'd be up to 30. Then 3 seconds, I'd have to find the whole area of this here. So I'd have to split this up into rectangles and triangles, because that's the only thing we really can find the area of easily at this point. Right, and then I would actually, if I did that, I would find that it equals 37.5. Okay, and so that tells me where it is at any given time. And then if you get to 4 seconds, the height of this triangle, you're just looking for this big triangle now, is 20. The length is 4, so 4 times 20 divided by 2 gives me the area of the triangle, and that would be 40. All right, and so that's how we got that the displacement at the end is 40. All right, so that would take a little more work, but this is what once again, this is what the position versus time graph would look like. This is something speeding up and slowing down. And if we go back to the time and position graph, this is just something that is starting away from you, moving towards you at a constant velocity. So two completely different things you always have to look at, whether it's talking about position or whether it's talking about velocity.